Hello, friends. So we're going to talk about vectors from an algebraic perspective. So I'm going to introduce them again. So in another video, I introduced vectors from a geometric perspective. And just a content warning or note, you might hear snoring. My dog is snoring behind me. So if you hear snoring, I think I'm boring her to death. Okay. Vectors are defined algebraically using the rectangular coordinate system using this notation. So you've still got your vector notation, but we have these angular brackets, and these should be softer than like the normal bracket that you see on the keyboard. Usually when we try to draw these brackets, we try to draw them a little softer. Mine end up not looking quite as soft, but that's kind of the goal. So that's how you know it's a vector, is it has like a softer angular bracket. Okay, so let's just talk about, so from the algebraic perspective, so in the Cartesian coordinate system, as we call this, the way that we interpret the vector, so you start at the origin, and then you've got your point, AB, and then you connect them, and there's your vector AB. Okay, so I just want to make sure that you understand this. When you draw the vector, you do not go through AB and keep going, okay? So a vector, it's an arrow with a set amount of length. So if you continue it, that is wrong, and then that's a different vector. And then the other thing I want to point out, so this is the vector. So with these brackets, this indicates that we're talking about a vector and not a point, though we use the point to come up with the vector. Okay, so some clarifications. All right, so geometrically, which is what I talked about in the other video, geometrically we think of a vector as just a line segment with direction. And algebraically, we think of a vector as a different type of ordered pair. So I bring that up because vector is an ordered pair, and so is a point. So I think of it as like its own type of ordered pair with angular brackets. So these are the same thing, but it's just like depending on your context, you might want to think about things geometrically versus algebraically. So usually algebraically, then you're bringing in like the Cartesian coordinate system or whatever. All right, so let's define direction angle in this context. So I've got my vector u. So this angle theta, the positive angle between the x-axis and the position vector, this is our direction angle. So that's what makes that. So we start here, get a vector. This is the direction angle. So let's talk about how to calculate magnitude now. This is actually much easier than what we were doing in the last set of videos. To calculate magnitude, so you've got your ordered pair, you just take the square root of a squared plus b squared, so it's a lot faster than what we were doing before. And then to figure out what that direction angle is, so we have just this nice little formula, so it's tangent of theta equals b over a. Alrighty, so let's calculate the direction angle and magnitude for this vector u. Okay, personally, I've given you the formulas. I think that you can do this. I would say you should pause and try this on your own just to make sure you understand. So the magnitude, which I indicate by drawing the absolute value, looks like absolute value, isn't absolute value, right? It means something different in this context. Anyways, take the square root of 5 squared plus 2 squared, so that's going to be the square root of 29. Okay, direction angle. So I take tangent of theta, so 2 over 5, b over a. So now I have to take the inverse tangent to get to theta, so then my angle would be 21.8 degrees. Okay, so we also have what's known as horizontal and vertical components of a vector. And okay, so I've got my vector here, it's my point AB. All right, so the vertical component, so the horizontal component, you start from the origin, you go out to where that point A is, that's the horizontal component. This part B, that's the vertical component. So everything's kind of connected. And A and B do have their own formulas, so I don't think that this is too crazy to figure out. So you've got obviously a right triangle here, so you can figure out why A and B equal these things. So A is equal to the magnitude of u times cosine of theta. B is equal to the magnitude of u times sine of theta. So what if I asked you a vector has magnitude 36 and direction angle 35 degrees, and I wanted you to find the horizontal and vertical components? Okay, so I gave you some formulas, right? So I think you can do this. I think you should pause, try those formulas, and then hit play. Okay, so using those formulas. So I have my magnitude. So magnitude times cosine of the direction angle. Magnitude times sine of the direction angle. So just plugging and chugging with those formulas. It's pretty straightforward. So I get 29.5 and 20.6. Okay, so what if I wanted to figure out what the vectors were from, say, a sketch? Okay, so I've got two different vectors here. So you're really given the magnitude and the direction angle, but now this is just kind of maybe bringing it more alive, I guess. So to figure out how to write this vector u in this AB bracket form, so I take the magnitude times cosine of my direction angle, and then the magnitude 6 times sine of my direction angle. So I can just do those computations to get, here's my u. I would suggest that you try finding w on your own and then just hit play when you're ready. So if I want to set up for my w vector, here's my calculations, and so then there is what I got, and I rounded. Okay, so vector operations. I've got 4 different vector operations. So here's the thing with math, like where you're going with math. When you're given a list like this, it's very important to notice what you have been given and what you have not been given. So I've been told how to add vectors. I've been told, so this k is what's known as a scalar, so I know how to take some random number and multiply it into the vector. So I do that by taking that number times both components of the vector. We've kind of talked about this before, so if I have some vector is made up of a comma b, then the negative version of that vector will just be the negative components. And then if I wanted to do, say, one vector minus another, I could think of that as taking the first vector plus the scalar -1 times that vector, and it looks like subtraction. So just the thing I'm trying to point out here, it's very easy to just look at this and say, oh, subtraction just works. But what you're being told here is that this is actually addition with a scalar multiplication. So it's the combination of rules 1 and 2 together. Okay, so notice that these are the operations I gave you. What operations did I not give you? I didn't give you multiplication. I did not give you division. So it's very important to adopt a mindset to look through a list like this and get in the habit of saying, oh, I don't have multiplication and division. I can make no assumptions on how to do that. So yeah, as it stands right now, multiplication and division do not exist, minus the place where we have this scalar multiplication. So I can take a number times the vector, but I cannot take one vector times another. At this moment in time, no rules for that. We can't do it, okay? So that's just a thing to get used to as you go through higher levels of mathematics every single time. If you just take that extra second to critically think, you will thank yourself later. Okay, so let's just talk about how to work with these operations. I think it's pretty straightforward. So if I wanted to add the vectors u and v, and here's my vectors u and v, so all I have to do is I just take their components and I add them. So the first components I add, second components I add, and so I get 211 as my vector. Now, we want to, this should say find and illustrate. Sorry, that was my writing errors. Okay, so anyway, so to illustrate, all right, so here's my sketch. So notice, so for u, I go to -3, 4, there's my vector. For v, I go to 5, 7, there's my vector. And then for the combination, so now I have to go to 211, so I can just count that out. So there's my other vector. Okay, so now I've got some scalar multiplication, just so we can practice that a little bit. So I've got -3 times the vector u and then 2 times vector v. Okay, so I'm going to take 3 times this vector and 2 times this vector. So if I do that, this becomes negative 3, and 12. So right, 3 times negative 3 is negative 9. And sorry, this is negative 9 and 12. And then 3 times 4 is 12. And then 2 times 5 is 10. 2 times 7 is 14. So hopefully that's clear. And then I just add the components. So negative 9 and 10 is 1. 12 and 14 is 26. So I would say maybe just try to sketch this just to make sure that that makes sense to you. Just maybe pause and quickly draw the sketch. So, okay, I have now, so negative 3, 4, and I've drawn this in like quantities of 5. So I'm at, let's see. So this is the vector negative 3v. So I didn't draw u. Okay, and oops, I just realized I had my notation flipped, so I flipped it back. Okay, so there's negative 3u 2v, so you can just see that I used these points, if you will, and then there's the combination of the two. Okay, so the last thing I want to tell you about is the ij form of vectors, because vectors get used all over the place. So a lot of times when we refer to vectors, we have the ij form. So if I have ab as my vector form, the ij form is by taking a times this I vector. So these become numbers. So now a becomes a number times the vector I, and b becomes a number times the vector I. So notice how the vector notation just looks now, okay? So I is the vector 1, 0, j is the vector 0, 1. Again, really common form of vectors. So if I wanted to take this vector 3, 5 and put it into ij form, I would write it as 3i plus 5j. And then if I wanted to go the other way, so say if I had 2i minus 4j and I wanted to put it back in that bracket form, I would write it as 2, negative 4. So hopefully that makes sense. And okay, so that is your intro to vectors from the algebraic perspective. If you found that helpful, consider liking, commenting, sharing, subscribing. It helps me so much. And okay, guys, so that's it for this one. I will catch you guys in the next video.